We have a very interesting function, natural log of natural log x. It's a composite function. To appreciate this, understand what's going on, I have an input coming into the x. I do a natural log x. That output becomes the input for your next natural log. How can I understand its graph? Think back to your basic natural log graph. It has an x-intercept 1, comma 0. Because when I do natural log of 1, I have an output 0, and it makes sense. If I do natural log of 0, it's not defined. So we have a x equals 0, which is your y-axis, as your vertical asymptote, and we have a x-intercept 1, comma 0 for this basic function. But now I'm looking at natural log of natural log x. What happens if I put this one value in this new function? I'll have a natural log 1, which is a 0. 0 becomes the input for the other, and it's not defined. So now we're saying we have a new vertical asymptote, x is equal to 1. The original x-intercept now no longer is valid, so it becomes a vertical asymptote. That means I have an x-intercept somewhere here, and how can I determine that? If I were to put natural log of e, I'm getting here a 1, then natural log of that 1 becomes a 0. So I see clearly the e comma 0 is my new x-intercept, and my graph looks something like this. This here is natural log of natural log x. If you couldn't deduce this, you can easily calculate it. At an x-intercept, you know you have a certain x value and your y value is always 0. So make your y value 0 and solve for x. Push this on the other side. I have a natural log x is equal to e to the power 0, which is equal to 1. Now push the second natural log on the other side. X here is equal to e to the power 1, which is equal to e. My x-intercept is e comma 0, and you see it, and it's correct. New vertical asymptote, x is equal to 1.